Hello, exam scholars. You're welcome to the first mathematics video lecture for preparing us towards a JAMB. So, my name is Oladimeji Shekun Olawale, also known as Inspired Diner. So, being the first video, we are going to look at indices. So, under indices, we are not just going to start straight. We are going to look at elementary algebra, what you need to know. And then we have the law of indices. I'm going to cover all the law of indices, including the law that you are not aware of. Then we are going to solve examples. So make sure you watch this video to the very end and get your pen, your book. You don't need a calculator. Just get your pen and your book and follow this video strictly. Even if you think you know indices, this video will help you. If you know it better. If you know it, you increase your speed while watching this video. Now, what are the elementary things that you need to know if you don't want to struggle with indices? The first thing is you must understand this. Anything raised to power 0 is equals to 1. So a raised to power 0 is equals to 1. 70 raised to power 0 is equals to 1. This one that you are seeing here, I can write it in many ways. I can even write 100 raised to power 0 is equals to 1. I can write a raised to power 0 is equals to b raised to power 0 because anything raised to power 0 is equals to 1. I can write 1.777 raised to power 0 is still the same thing as 3 raised to power 0. So master this. We are going to need it while solving our exponential equation. Now, a that is here, we also have an invisible one that is standing with a. So we have a raised to power 0. It means that we don't have a, so we have 1. Now let's go. A raised to power 1 means we only have a once. A raised to power 1 is still the same thing as a. Now a raised to power 2, now we have a twice. Multiplication, a times a. A raised to power 3, a times a times a. See it, I'm talking about multiplication, not addition. Now we have a raised to power 4, a times a times a times a. A raised to power 5, a times a times a times a times a, as you can see. Now let's look at 0. 0 is still the same thing as 0 here. Right? 0 here simply means 0 multiplied by a. So 0 multiplied by any number is still what? 0. A simply means how many a do we have here? 1a. And let's do this. A plus a is equals to 2a. A in two places. A plus a, we have 2a. A plus a plus a, we have how many a? 3a. So it means that a plus a plus a is still the same thing as 3 multiplied by a. Get this. 1, 2, 3. A in 3 places. We have a plus a plus a plus a, we have 4a. And we have a plus a plus a plus a plus a, we have 5a. The next thing you need to understand is this sign. Plus times plus is equals to plus. Minus times minus is equals to plus. Now look at this. When you have two signs multiplying each other and the two signs are the same, you don't need to cram anything here. When the two signs are the same, your answer will always be plus. Plus times plus, plus. Minus times minus, plus, because both of them are the same. So when one of it is different, you have minus. So which means that plus times minus will give you minus. Why? Because they are not the same. Minus times plus will also give you minus. So another thing that you need to know here is BODMAS. Now, when we say BODMAS is just like when you have multiple operation in mathematics, you are given a question whereby you have plus, you have addition, you have so many things inside that question. How are you going to solve your question? Because you should have a starting point. So BODMAS is just like a scale of preference while solving question. Scale of what? Scale of preference, the order of importance. Now the first one is bracket. So when you are given a question and you have bracket, it means that you deal with what is inside your bracket first. Deal with what? What is inside the bracket first. Now you have your O. O means order. After you have dealt with what is inside your bracket, then you now look at the order. Order simply means some operation in mathematics that is different from addition, multiplication, division, plus and minus. Now, for instance, we have power and we have root. So when you have it in your question, you deal with it first. After dealing with bracket, you do this. That is order. Then that is when you can now look at the division in your question. So you can start dividing, then followed by what? Multiplication. Multiplication also means off. Now we have our addition. plus, followed by what? Your subtraction. This is the meaning of BODMAS. Don't stress yourself. We are just giving order of importance. What are you supposed to do first? Let's have a simple example to test our knowledge about all this. Now here we have this question. Simplify the following. 6x minus 4x multiply or times 2x plus 6x cubed minus 5x. The second question, minus 10x plus 4x squared. The third question, 3ab plus 4b minus 4a plus 6b minus 10ab. The last one, minus 6 multiplied by 4x squared. Let's see how to quickly solve this question. The first one here, look at this. Now we have minus here, we have multiplication here, we have addition here, we have subtraction here. Now we need to apply BODMAS. I know some of you just go ahead and do 6x minus 4x. You get your 2x and you multiply it with this one, 4x. Now if you do it that way, you will miss it. The funniest part of it is that if you do it that way, the answer that you are going to get will still be in the option if you're writing down. So, and you choose the wrong option. So let's apply BODMAS. Now, between subtraction, multiplication, and addition, which one should come first using this BODMAS, which is scale of preference for mathematics operation? Now, the first one is multiplication. So your multiplication comes first. So where is our multiplication here? We have minus 4x multiplied by 2x. That is what you're supposed to do first. Now, minus 4x multiplied by 2x, you get to minus 8x squared. Coming from what we have here. When you have a multiplied by a, you have a squared. X times x, you have x squared. 2 times minus 4, you have minus 8. So you now have your minus 8 squared. Now let's rewrite that. So we are going to have what? 6x minus 8x squared. Then you have this plus 6x cubed minus 5x. What you have here. Now the next thing to do here is to collect like terms. Collect like terms. Now let me say this. In mathematics, when you have something like this, you should start with the one that is having the highest power. So, but notwithstanding, let's solve it this way. Now we have our 6x that is here. Now you bring this one to your 6x. Let me say this again. When you have an expression like this, the sign before that expression, the expression owns that sign. For instance, this 6x cubed, what is the sign before it? It is plus. So this 6x cubed owns this plus. So if you want to carry this 6x cubed, you carry it with the sign. So when you want to carry this 5x, what is the sign before it? It is minus. So you don't just carry 5x, you carry it along with the sign minus 5x. So that is why we have 6x minus 5x. Then you have your minus 8x squared plus 6x cubed. So what is 6x minus 5x? You have your x. So we are going to have something that looks like this. We have our x minus 8x squared plus 6x cubed. Now you can factorize your answer. When you factorize your answer, you have your x outside. X divided by x, you have 1. 8x squared or minus 8x squared divided by x, you are left with minus 8x. Now plus 6x cubed divided by x, you are left with plus 6x squared. You can rewrite this. What do I mean by writing it? Your 6x squared can come first, or plus 6x squared coming first, then followed by minus 8x, then followed by plus 1. You can see it that way. Now let's move to the next question. The next question that we have here, we have minus 10x plus 4x squared. You know, some students will just go ahead and write, they can just go ahead and write, what is minus 10 plus 4? We have minus 6. They can write minus 6x or minus 6x cubed or minus 6x squared. I wonder. Now, this thing, they are not the same. Look at this. This one is x. This one is x squared. You can't add them together. You cannot subtract them. They are not the same. It's just as if you want to add 10 naira plus $5. And you are saying $15 naira or 15 naira dollar. Is that making sense? No, you have to convert it to the same unit. The same thing applicable to algebra. This is different from this. So you cannot add them. You can do every other thing, but you cannot add them. Now let's see how to solve it. So instead of having this, you can start with your 4x squared. So instead of having minus 10x plus 4x squared, you can start with your 4x squared minus 10x. Now, what can you do here? You can factorize them from your primary school or from your GSS class. Now, 2 can divide this, x can also divide this. 2 can divide this, x can also divide this. So bring it outside. So you have your 2x outside. You will now go ahead and divide this by 2x. You'll be left with what? 2x. Now 2x divided by 4x squared, you are left with what? 2x. Minus 10x divided by 2x, you are left with what? Minus 5. That's all. Now let's move to number 3, which is quite interesting. The third question here. To solve this, I intentionally put this question. 4b is still the same thing as 4ab. They are the same. 4ba still the same thing as 4ab. So let's collect our like terms. Collecting your like terms, you are going to have your 3ab plus 4ba. Then you have your minus 10ab, which is here. I've told you the other time. Then what do you have next? Minus 4a, what you have here, plus 6b, what you have here. Now you can add these and subtract them. This one, they are the same. So what is 3ab plus 4ab? You have 7ab. 7ab minus 10ab, you have minus 3ab. So we now have our what? Minus 3ab minus 4a plus 6b. Let me say this again for the last time. You can add them together. This is ab, this is a, this is a, this is b. Don't go ahead and add them together. I know some of you just have 4a plus 6b. You just have 10ab. No, you can't add it. They are not the same. So these are final answer. Well, you can rearrange it. You can bring your 6b first, which means 6b minus 4a minus 3ab. Anyhow, for the last question that we have here, minus 6 multiplied by 4 here, you are going to get minus 24. Then you have your x squared, minus 24x squared. Now let's see this. What is the sign before this 4? It is plus. You don't use to write plus that much. Now you have plus times minus, you have minus. Let's say you now have minus 6 times minus 4x squared. What will be your answer? 24x squared or plus 24x squared. Before we proceed, let's quickly learn this. It will help us in the law of indices. The first one is 2 raised to power 0 is 1. 2 raised to power 1 is 2. 2 raised to power 2 is 4. 2 raised to power 3 is 8. You don't know how I do it. It's very simple. 2 raised to power 0, you have your 1. Anything raised to power 0 is 1. 2 raised to power 1, 2. Just 1, 2. 2 raised to power 2, that will give you what? 2 times 2. That is 4. 2 raised to power 3, that will give us 2 raised to power 2 times 2, or 2 times 2 times 2. 2 times 2, 4. Yeah, times 2, 8. Now 2 raised to power 4, that will give us 16. 2 times 2 times 2 times 2, that will give us 16. That is 8 times 2. The next one, 2 raised to power 5, you have 32. 2 raised to power 6, you have 64. You just be doubling this one. 2 raised to power 7, you have 128. 2 raised to power 8, you have 256. 2 raised to power 9, you have 512. And we are stopping here. 2 raised to power 10, 1024. Or maybe 2 raised to power 11, 2048. Let's quickly do 3. 3 raised to power 0 is 1. Master this. Master this for indices and logarithm. 3 raised to power 0 is 1. 3 raised to power 1 is 3. 3 raised to power 2 is 9. And 3 raised to power 3 is 27. It's very simple. 3 times 3, 9 times 3, 27. It's just be multiplying this by 3. 3 raised to power 4 is 81. 3 raised to power 5 is 243. 3 raised to power 6 is 729. And 3 raised to power 7 is 2187. For your JAMB, you just need it up to 3 raised to power 6. Don't stress yourself. And let's finish it. 3 raised to power 8 is 6561. 3 raised to power 9 is 19,683. e raised to the power 10, 59,049. Let's do 4. 4 raised to the power 0, 1. 4 raised to the power 1 is 4. 4 raised to the power 2, that's 4 times 4, 16. 4 raised to the power 3, that's 4 times 4, 16 times 4, 64. 4 raised to the power 4, 4 times 4, 16 times 4, 64 times 4, 256. Then 4 raised to the power 5, 1024. Let's stop here. We're not going far. Let's observe something here. Everything you have here, you still have them here. Let's look at 4 raised to the power 1, which is 4. It's still the same thing as well. 2 raised to the power 2. So which means that this 4 you can turn it to 2 raised to the power 2. Now, let's quickly observe this one before I proceed. Now, 4 raised to the power 3 is 64, right? It will still be the same thing as 2 raised to the power 6. Wow. Oh, yeah. 4 raised to the power 4, which is 256. It will be still the same thing as well. 2 raised to the power 8. It's very simple. 4 here, you can turn it to what? 2 raised to the power 2. The power here, you can multiply it with 4. That will give us 8. 2 raised to the power 8 is still the same thing as 4 raised to the power 4. Now to 5. 5 raised to the power 0 is 1. 5 raised to the power 1 is 5. 5 raised to the power 2 is 25. 5 times 5. 5 raised to the power 3 is 125. 5 times 5, 25 times 5, 125. 5 raised to the power 4 is 625. And 5 raised to the power 5 is 3,125. Another thing that you quickly need to know is power and root. So when you hear power, what's the meaning of power? When you hear root, what's the meaning of root? So let's use what we have here to learn them. Now, when you hear raised to the power of 2, it has a general name which means square. So when you hear a raised to the power 2, it also means a square. A raised to the power 2 also means a square, or the square of a. So the square of 2 is what? 4, which simply means 2 times 2. Square of 3 or 3 square, it means 3 raised to the power 2, which is 3 times 3, 9. Square of 4, 4 raised to the power 2, 4 times 4, 16. The same thing applicable to 5. Now, let's come back to 3. Raised to the power 3. When you hear raised to the power 3, it has a general name which means cube. The cube of 2 is 2 times 2 times 2, which is 8. So when you hear the cube of a, it means a raised to the power 3. No doubt about it. The cube of 3, 3 raised to the power 3, which is 3 times 3, 9 times 3, 27. When you hear 2 raised to the power 4, it means 2 times 2 times 2 times 2, which is 16. Is that okay? Now let's now talk about the root. When you hear square root is the inverse of square. When you hear the square of 2 is 4, the square root of 4 will now be 2. The cube of 2 is 8. The cube root of 8 will now be 2. 2 raised to the power 4 is 16. The fourth root of 16 is 2. Let's use 3. The cube of 3 is 27. The cube root of 27 is 3. Let's use 4. 4 raised to the power 5, or the fifth power of 4, is 1024. The fifth power of 4, which is 4 raised to the power 5, is 1024. Now, the fifth root of 1024 will also be 4. Let's move down to 5. The fourth power of 5 is 625. The fourth root of 625 here will also be 5. Now, that one will lead us to another thing, which is called perfect square number. Now, perfect square numbers are numbers that when you find their square root, you get a number. So to find perfect square number is very simple. You start with your 1. 1 times 1, 1. 2 times 2, 4. The first perfect square number is 1. The next one is 4. The next one is 9. 3 times 3, 9. The next one is what? 16. So let's start. The first one, 1. The second one, 4. You just look at this. If we continue this, all these numbers are called perfect square number. The first one is 1. 1 times 1, 1. 1 is a perfect square number, followed by 4. 2 times 2, 4. Perfect square number. 9, perfect square number. 16, perfect square number. 25, perfect square number. 36, and so on, up to 100. We have more than that. 11 times 11, 121. 12 times 12, 144, and the like. So they are perfect square number. So when you find the square root of all this number, you get whole number. Any number that is apart from perfect square number, their square root will be decimal number. You get point. And automatically they are going to be what we know as irrational number. That is what we call SOD. Now let's look at perfect cube number. Now perfect cube number is all this number. We're talking about all these numbers. Now the first perfect cube number is also 1. 1 times 1, 1 times 1, 1. So the next one is 2 times 2 times 2, which is 8. The next one, 3 times 3, 9 times 3, 27. The next one, 4 times 4, 16 times 4, 64. The next one, 5 times 5, 25 times 5, 125. The next one, 6 times 6, 36 times 6, 216. The next one, 7 times 7, 49 times 7, 343 is a perfect cube number. The next one, which is 8 times 8, 64. 64 times 8, 512. 512 perfect cube, and up to 1000. So which means that if you find the cube root of all these numbers, you get whole number. So when you continue this number like that, any number apart from perfect cube number, you find their cube root, you are going to get decimal, irrational number as well. So you are going to get decimal. So that is perfect cube number and perfect square number. Because when we are dealing with indices, you are going to have some numbers and the power will be fraction. Fraction means you find the root. Is that okay? So you have your numerator as 1. Denominator will now be numbers. So the understanding of perfect square, perfect cube, perfect fourth number, perfect fifth number, perfect sixth number, we help you to solve your JAMB question very fast. You will see it when we are solving the question. Let's start our law of indices. Now, to understand indices, what is the meaning of indices? Indices means power, is a plural form of index. Now, you have a raised to the power m as shown here. This m, which is the power, it means index. It means index. Now, this is what? Index or power. Now, law of indices, when you are doing different operation as regard power, what are the laws that guides them? That is law of indices. The first one is anything raised to power 0 is equals to what? Is equals to 1. I've explained this earlier on. Now the first law is law of addition and subtraction of power. When are you going to add power or subtract power? Let's look at this example. A raised to power m multiplied by a raised to power n is simply a raised to power m plus n. It's very simple. Now, these two things must be the same thing. That is when you can add their power together. The one that is carrying something, it must be the same thing for you to add their power. When they are not the same thing, you don't add the power together. For instance, 2 raised to power 4 times 2 raised to power 6. That will give you what? 2 raised to power 10. You cannot do 2 raised to power 4 times 3 raised to power 2. You can't do it. You cannot add their power because they are not the same. I've said so. I've explained that too. Now, the next one, a raised to power m divided by a raised to power n. You know, division also means over, isn't it? So you have your a raised to power m over or divided by a raised to power n. And that will give you what? A raised to power m minus n. So let's say in question, you have something as your denominator. And that thing that is carrying something is the same thing with your numerator. So you can easily use this to solve them. Don't be looking for this division sign up and down while you're solving indices. When you see something like this, you can apply your law of indices ASAP. Now let's combine these two laws together. That is what I said when we want to start this class. Be smart as a student. Let me teach you one trick. Now what is that trick? Let's combine these two laws together. What if you have a times a raised to power x times a raised to power y divided by a raised to power z? How are you going to solve it? It's already here. Now let me show you one after the other. Now this expression is still the same thing as a raised to power x divided by a raised to power z multiplied by this a raised to power y. So you can see an expression like this. You still see this. Now this thing that you are looking at is still the same thing as what? A raised to power x times a raised to power y, what you have here, multiplied by 1 over this 1 over a raised to power z. So I'm rewriting this using different ways. Well, let's apply the law of indices. So when you see something like this thing that I'm showing you, it means that A. So you can add and subtract their power, isn't it? So you have your x plus y, because we have multiplication here, and you have this one as a denominator, minus z. X plus y minus z. So we've combined these two laws and we can start using them, isn't it? Let's look at this JAMB past question that you have here. How can we solve this very fast? Now, to solve this, you have your 3 raised to power minus 5n as a numerator. Your denominator is 9 raised to power 1 minus n. Abi, now this 9 is still the same thing as 3 raised to power 2. This 27 you have here is still the same thing as what? 3 raised to power 3. Yes, let's do it. You have your what? 3 raised to power minus 5 as one thing you have like this, and you have your 3 raised to power 2. This 9, it has turned to 3 raised to power 2. Now, this 9 has its initial power, which is 1 minus n. 1 minus n. So, which means these two will multiply 1 minus n. This 3 raised to power 2, 1 minus n, multiplied by, what is your 27? 27 is 3 raised to power 3. What you have here. And the initial power that is having n plus 1. You have it. The next step is to expand it. So let's see how to expand it. You have your 3 raised to power minus 5n over, now 2 multiplied by 1 here, you have 2. 2 multiplied by minus n, you have minus 2n. Then you use your 3 to expand this as well. 3 multiplied by n here, you have 3n. 3 multiplied by 1 here, you have plus 3. Now you have this. What is the next step? The next step is to apply your law of indices very fast. Yeah, let's go. This law that I've explained now. This guy, you are multiplying it with this guy. So you will add the power minus this. So we have 3 raised to power minus 5n, Abi, plus, you are multiplying this, 3n plus 3. Then your denominator, what you have here, minus. Now, when you are applying minus, for God's sake, let me explain this again. You are doing subtraction and you have two things that are together. You must open bracket for them. It is only when you have plus that you don't need to open any bracket. Plus does not change the sign of anything you are multiplying it with. Plus will not change the sign. Oh yeah, let me prove it for you. If something is plus and you multiply plus with that thing, will the sign change? The sign of that thing will also be what? Plus. Okay. If something is minus before and you multiply plus with it, that will be the final sign. The final sign will also be what? Minus. So that is why we don't care when we are adding something together. When we have something like this and you're adding it together, you see that I didn't use bracket for it. It's because I'm using plus. But when it comes to minus, I will open bracket. If you don't open bracket, now let's open. Let me prove it for you. When you multiply minus with anything, minus will change the sign of that thing. Something is plus before, you multiply minus by it. Your final answer will be what? Minus. Something is minus before, you multiply minus by it. Your final answer will be what? Plus. That is why you need to open bracket for minus. So now we open bracket for our minus here. Minus. Now open bracket 2 minus 2 here. Now let's solve it. We get 3 raised to power minus 5n plus 3n plus 3 minus 2 plus 2n. So you have minus 2. What is minus 1 times 2? Minus 2 minus 1 times minus 2n plus 2n. Now let's solve this. You collect your like terms. So you have minus 5n plus 3n plus 2n. This one. Then your plus 3 minus 2. Now let's solve the whole of this. Minus 5n plus 3n minus 2n. Minus 2n plus 2n. 0n. Nothing again. 3 minus 2. 1. The answer is 3 raised to power 1. Which is still the same thing as 3. So let's look at the next law, which is inverse or reciprocal law. Inverse simply means reciprocal. When you hear the word inverse, raised to power minus 1. We have two types of inverse in mathematics. But when you hear inverse, inverse simply means multiplicative inverse. Another type of inverse that we have is additive inverse. Additive inverse simply means you multiply that number, you multiply that thing by minus 1. What about inverse in mathematics or reciprocal in mathematics? It simply means you raise the power of that thing by minus 1. That is different between additive inverse and multiplicative inverse. This law is saying that a raised to the power minus m will give you 1 over a raised to the power n. So if I ask you what is the reciprocal of 2, the reciprocal of 2 will be what? 2 raised to the power minus 1, and that is what? 1 over 2. So if I now ask you what is the additive inverse of 2, additive inverse of 2 will now be what? Minus 2. Now for fraction, what is the inverse of 2 over 3? For fraction, you swap it. The inverse will be what? 3 over 2. The inverse of 2 over 3 or the reciprocal of 2 over 3 will be 1 over 2 over 3. So when you do it, you swap it. 3 over 2. Now let's proceed this law. Let's learn another law before we solve the next question. This law is meant for fraction and decimal index. This one, I call it fraction and decimal index law. So what if you have something and the power of that thing is not whole number, it is fraction or decimal? How do you solve it? For instance, a raised to the power m over n. You get this? Let me break it down. So the one at your numerator, it becomes power. Denominator, it becomes root. Numerator, power. Denominator, root. So a raised to the power m over n is still the same thing as what? A raised to the power m, a to the power of m. Now you now root it to that of n, nth root of a raised to the power m. You can do it this way, which means that you give preference to the power before the root. It's still the same thing as giving preference to the root before the power. So which means that you can use this or you use this, you still get the same thing. So you now have what? Nth root of a here, and the whole of the, and everything you raise the power by what? N. You still get the same. Okay? Now let's now apply this law and this law. Let's combine them together. What if you now have a raised to the power minus m over n? Minus means what? 1 over. So you now have 1 over this guy. It's still the same thing as what? 1 over a raised to the power minus m over n. So when you do it, you get this, get this. Let's solve this question. Evaluate 81 over 16. You close the bracket, raised to the power minus 1 over 4, multiply by 2, raised to the power minus 1. How do you solve this? You can solve it very fast. Let me show you how to solve it. To solve this, yes, this one, you turn it to what? 1 over 81. So you turn into what? 1 over 81 over 16 raised to the power 1 over 4 times, what is 2 raised to the power minus 1? 1 over 2. And you get 1 over. Now for this guy, let me explain this. There is one thing when it comes to power. If you have fraction for power, and your denominator and numerator can choose the power separately. Is that okay? So when you have a over b and everything is raised to power another thing, the two of them can take the power separately, individually. So 81 can have the whole of 1 over 4 here, and 16 can have the whole of 1 over 4 here, the power. So that is what we have here. Now 1 over 4, the power here, the one that is your numerator is 1, isn't it? The one that is your denominator is 4, isn't it? Which means the fourth root. Now let me say this again. Fourth root of 81 is different from 4 root 81. So we have Fourth root of 81 means a number that you will multiply by itself 4 times that will give you 81. Fourth root of 16 is a number that you multiply by itself 4 times that will give you 16. So fourth root of 81 will now be what? 3. For 16 will now be what? 2. So we have what? 1 over 3 over 2 times 1 over 2. I've explained this inverse. So you get your 1 divided by 3 over 2 here times 1 over 2. Finally, you have what? 1 times 2 over 3 times 1 over 2. You see? This one has turned to 2 over 3. So finally, your 2, we cancel these 2 here. 1 here. And you have your 3 as your denominator, 1 over 3. 1 over 3 is still the same thing about 3 raised to power minus 1. How can you now solve this question very fast without stressing yourself? Yes, we can solve it. Now let me show you. For smart students, you have 81 here, you have 16 here, isn't it? And you have minus here. So you have fraction here. It means that your 16 will come up, 81 will come down, isn't it? Now you have your 4 here as a denominator. Each means what? The fourth root. What is the fourth root of 16? That is 2. 2 over fourth root of 81, 3. So you have 2 over 3 here. Everything here is already 2 over 3. Multiply by 1 over 2. Yes, the 2 will cancel 2, so you have left it what? 1 over 3. Without even using calculator or using your pen to write anything. And let me add bonus. This is bonus. This law is actually bonus for you guys. What if we have different things and each of them is having their own power? A raised to power k multiplied by b is with b raised to power l and multiplied by c raised to power m, and outside the whole of everything is having power outside, which is n. It's very simple. Now you now pick this power n, you multiply it by the power inside, so which means a raised to power k n, b raised to power what? L n, and c raised to power what? m n. That is the law. Now let's see how to use this law to solve a question very fast. This question, can we simplify it? Simplify 24 raised to power m times 210 raised to power m over 14 raised to power 2m times 7 raised to power 2m times 9 raised to power 2m times 40 raised to power 2m. But if you look at these guys very well, you see that they don't even have something in common when it comes to law of indices. How do we now solve it when they don't have something in common? We can apply that law, this law. We can apply this law. Now look at 14. 14 is also 2 times 7. Okay. 9 is 3 raised to power 2. If you look at 40, 40 is also what? 4 times 10. And your 10 is 2 times 5. 40 is 8 times 5. 8 is already 2 raised to power 3. You have 5 here. And if you look at 210, 210 is also 21 times 10. 21 is 3 times 7. Okay, let's come to 20. 20 is also what? 4 times 5. And that 4 is 2 raised to power something. 24 is what? 6 times 4. This same 24 is 8 times what? 8 times 3. Okay, now let's break it down. What we have here can turn to this. You have your 24, 8 times 3 raised to power m. You have your 20, 4 times 5 raised to power 2m. You have your 210, 3 times 7, which is 21, times 5 times 2. Everything will give you 210. 5 times 2, 10. 3 times 7, 21. 21 times 10, 210 raised to power m. Now your 14 is still the same thing as 2 times 7. Your 9 is 3 raised to power 2. Abi? That will now give us 3 raised to power 2m. Your 40 is what? 8 times 5. What you have here. The next step is, let's now break it down. To break it down properly, we are going to have what? 8 raised to power m, 3 raised to power m, 4 raised to power 2m, 5 raised to power 2m, 3 raised to power m, 7 raised to power m times, I'm talking about multiplier now, times 5 raised to power m times 2 raised to power n. What you have here. Now let's look at our denominator. Your denominator, you have 2 raised to power 2n times 7 raised to the power 2m times 7 raised to the power 2m times 3 raised to the power 2m times 8 raised to the power 2m times 5 raised to the power 2m. Now look at this 8 here. We can still break it down to 2. 8 is still the same thing as 2 raised to the power 3. So instead of having 8 raised to the power m, we can have what 2 raised to the power 3m for this guy. The same thing applicable to this guy. This guy returns to 2 raised to the power what? 2 raised to the power 3. That is 8. Now that 3 will now multiply 2m. That will give us 6m. The same thing applicable to this 4 here. 2 raised to the power 2. And we have what? 2 raised to the power 4m. So let's break everything down. So 8 is already 2 raised to the power 3m. This one times 3m. This one 2 raised to the power 2m. 2 times 2m, you have 4m. What you have here? This one 5m. This one 3m. This one 7m. This one 5m. And this one is 2m. This one 2m. 7. This one is 2m again. 7 raised to the power 2m. This one is what? 7 raised to the power 2m. 3 raised to the power 2m. This one will now turn to what? 2 raised to the power 6m. Let me explain. 8 is already 2 raised to the power 3. That 3 multiplied by 2m, you have 6m. Finally, 5m. Yes, we can now apply a law of indices. You have 2 here. You have 3 here. We only have 2, 3, 5, and 7. So let's break them down. Picking your 2. 2 raised to the power 3m. Where's another 2 here? This one. Plus 4m. What you have here. Where's another 2 here? This one. Plus m. Where's another 2 here? Denominator minus 2m. Where's another 2 here? Then you have your what? Minus 6m. What you have for 2. We are done with 2. Go straight to 3. 3 raised to the power what? 3 raised to the power m. What you have here? Where's another 3 plus m? Where is another 3? Denominator minus 2m. It remains our 5. The first 5 raised to the power 2m. Where's another 5? Plus m here. Where's another 5? Minus 2m. We are done with 5. Now let's move to 7. 7 raised to the power what? M here. Where's another m? Minus 2m. Your denominator. That is why it is minus. Then where's another m? Here. Minus 2m. See, that is simple. Now let's solve this amazing question. Now for 2, come over to 2. 3m plus 4m, 7m plus m, 8m minus 2m, 6m minus 6m, 0m or 0. 2 raised to the power 0, 1. The whole of this turns to 1. Now let's move to this. 3 raised to the power m. Now m plus m, 2m minus 2m, 0. 3 raised to the power 0, 1. 1 times 1. Now let's come over here. 2m plus m, 3m minus 2m, m, 5m. The whole of this turns to 5m. Let's come over here. M minus 2m minus n minus 2m minus 3m. So the whole of this will now turn to what? 1 times 5 raised to the power m times 7 raised to the power minus 3m. This one is already 1. 1 times 1, 1. 1 times this is still this. Now let's apply this law again. You have m here. You have m here. You can bring the m outside. So making 5 times 7 raised to the power minus 3. You close the bracket. Now have your m outside. You can apply law of indices. Your 5 will be here. This 7 will come down 1 over. So that is why it's done. 7 raised to the power 3. Then you have your m outside. You can still have your answer this way. 5 over 3, 4, 3. Close the bracket. Everything raised to the power m. You see that is actually simple. Now we are able to learn all the law of indices in this video very fast. Yes. So I want to enjoy you guys to pick your past question. Thank God you have your Exam Scholar app. Now go on your app and look for as many questions as possible, because in my next class I'm going to solve one question for you in our discussion class. You can tell me what you don't understand in the discussion class. Alright, so give me the feedback after watching this video. If you're a science student, make sure you watch my next video, which is going to be on physics. All right, I'll see you in our discussion class. Comment, like, share this video.